Hello, this is Mike from Fair Repair, and today we have a really special job on my bench. This device is actually a customer job, and we even know the history of this device, which is actually pretty good and bad at the same time, because let me explain that in short. The board of this HP Pavilion died. If I remember correct, it was liquid damage. The customer has some basic technical knowledge and decided to replace the motherboard. However, he was not able to source the same motherboard model, but a newer one. And the guy who sold this to him told it is compatible. I don't know. We will see. The next problem was the board was not working. And it did not power on. And instead of returning the motherboard to the seller, the customer decided to fix it by himself. You know, the first tries are always a mess, and the second tries normally too. The third board I've tried to fix was also a no fix, so absolutely normal. And the guy who owns this device appeared on Discord. And I tried to help him. A lot, actually. I spent really much time. The problem with this board is we have no schematics. And the knowledge of the customer, how the board works, basically, was too less. So in the end, I was not really able to help him. We were always stuck at the charging controller, and steadily something was shorted and not working, and capacitors flew away, resistors flew away and were probably mixed up in the end, and there were issues with soldering the charging controller. So really we really had to sort a lot, and in the end I had to tell, I can't help you anymore. We cannot do it. However, thankful to a big coincidence, the device is on my bench, and now we'll take a closer look to what happened and whether we can fix it. What are the odds? I don't know. Something between fix and no fix. Can't tell right now. We'll start with a basic overview. We probably also perform a fast check of the whole board, whether there might be some more issues even, so we can instantly decide whether we can continue or to stop. Let's see. And we can still notice what happened here, here and here. Bad liquid damage with the old motherboard. This is the new one, and however it looks already very used. Hopefully we can do something for the customer. Good. This is really sad to see. This is an expensive board. I think the customer spent 300 euro or so. So let's check the power rails. So let's start with the GPU here. 50 ohms is good. This is good. Core supply, I think it is a RTX 3050. 2 ohms. Fits. This CPU has a fully integrated voltage regulator. So we have relatively high resistances to measure here. At least nothing clearly shorted. This is also okay. So when we have here the buck for the charging, and here probably 3.3 and 5 volts, which looks fine so far, luckily. Good. What do we have on the other side? Set in beep mode and check a few capacitors. Looks all fine. So, and the first thing we will do is to clean the area here. I don't like how it looks here. The area is pretty cooked already. Can you spot that? Here? How can we show here? The board is really cooked already. Which is bad, really bad. Too much heat for too long. I guess it's time to move under the microscope. And here we go. Here we go. Wow. Wow. Does this look any good to you? This transistor here looks melted. It looks melted. Can you see that? Actually, right now I'm not sure whether we can do that. So now let's take a look at the pins. Yeah, look at that. Does this look solid to you? Here. This is supposed to be full of solder, and it is not. Same here. And here we have one soldered pin. One soldered pin. This is a properly soldered pin. One so far, okay? On this side maybe a second pin here. Maybe not. It's a solder ball. Okay. What do you think? Can we do it? I'm not sure. So let's go or move around the controller and check for short to grounds. Let's go in beep mode. This was also one of the issues. It was not possible to get stable measurements. So we don't have any clear short to grounds, which is good. One good thing is we have a picture of from before all this happened, so at least partial we can work with this. Also I have sourced schematics from another board with the same controller, with the same configuration as hybrid charger. So we will do it in the following order. First, we'll solder this controller properly, and then we'll go around completely through the whole circuit and check for weird things, defective components, and something which is wrong, basically. Yeah, let's go. Maybe. Maybe, maybe not. But this looks now very nice. Very nice now. Huh? This looks nice now. Very good. Very, very good. I'm happy. I'm happy. So now the final question. Has the controller survived this torture? Let's see. Beep mode. Yes, it works. Good. What? 1 second. No. At the edges were small ground planes. This is why it beeped. This ground. This is supposed to be ground. pin 9, correct? And pin 9 is regarding my data sheet. Gate pin of the low side charging, so we have to solve that. It is probably just too much flux here. Let's see whether we can reduce it somehow. So let's see whether the short went away. No, it's still shorted to ground. Why? Why? So charging coil is here, so maybe it has continuity to this dual MOSFET. Let's see. So basically from here to here. Yeah, here. 5 ohms. This does not sound good. Here. 5.3 and 5.3. So here we have a short between gate and source, which is not supposed to be present. So the MOSFET might be gone. Here we go. So let's check again. So here we have ground, yeah, and here still shorted. So what do we have here? Yeah, it is shorted with this ground plane here, no? It is shorted with the ground plane. Ah, come on. It is shorted with the ground plane. How can we sort that? Now maybe. By any chance? Yeah, the short is gone. Okay. So I would say we proceed with the obvious, which is, for example, this diode here. I mean, I will replace it for sure. So 1.4, 1.5, 1.4. Are you trying to tell this diode is still any good? 1.6. And this way around? 0.3. 0.3. Seriously, I'll replace it. Whoops. Okay. Here we go. Not sure whether we did it properly, but for this questions we have our multimeter, yes? So between here and here, and we do have continuity. So good enough. So this one is soldered properly. What else? I don't know, should we try to power it on? Huh? Let's try to power it on before we mess with the resistors, okay? Let's see what happens. Maybe we are lucky. So, power. Let's see. No consumption. Nothing. Do we have main power rail present? What do you think? No? No. No, no, no. So now after the board decided to still not work, we'll concentrate on the mess which was done in the beginning of the repair attempt, of the previous repair attempt. We have this one, this one, this one, this one, and this one mixed up, and after some inspection I also realized this one here is missing. Here is supposed to be a resistor present. This is ground. So this is ground, clearly, and this here is pin 16, 17, 18, 19. And from here it is pretty simple. Pin 19 is AC in. And the resistor connected to ground has to be this one here, PR4485 in our example schematics, because this resistor here is not present in the 95522 configuration, only with the ISL 9538. So this is our resistor and has to measure 182 kilo ohms. So here is supposed to be our 182 kilo ohms resistor present, and now we have mega ohms, which is too much, obviously. Yes. Okay, like that maybe. So this is not nice, but it should do the job. So let's check again. Beep mode. So here we have our line. Internal resistance is 5 ohms, which is perfect. So what, should it do the job or not? Let's check this diode here. Is this diode okay? 03. Yeah, this diode is perfect. So what do you think? Fixed or not? Huh? This one resistor here in the end? So please work. We have consumption 70 milliamps, 33 milliamps. Everything fine here. 33, 37. What do you think? Do we have a main power rail? Any power? So where can I check for main power rail? Here maybe? No. And here we go, main power rail is present, 19.67. We have 3.4%. What is that? 5 volts present. What else? Here we have nothing. What else? What else? Here we have nothing. 1.8 for the PCH. Here maybe. No. No. Okay, however, we have some sort of function back. Let's check on the other side. So here are our DC in MOSFETs. If you remember, we had no power. Now we have 19 here, 19 here, and also 19 here. Yeah. And 19 at the current sense resistor. Alright? So gate voltage now should be 25 volts, no? 25 volts. Alright? So no tricks here. This was fixed properly. Okay, so the only thing which worries me right now is it consumes already a lot. 33 milliamps. Let's connect the power button. So how is it supposed to be connected? Like that? Here, no? Okay, let's see. So power. And now when I press a button, nothing happens. Nothing happens. Nothing happens. This is bad. This is bad. Let's check AC OK from the controller. Where was it? Here, no? No AC OK? Come on. Main power rail is present and I don't get AC OK. Why? I think it is actually turning on for a short while. Let's go in voltage mode. On. And yeah, look here. 200 millivolts. Oh my god, the PCH is gone. The PCH is gone. Most likely. "24 is here, no?" No? Okay, we have two resistors here. One is probably connected to ground, which is this one here, and one, this is our VDDP voltage. Okay. But why don't I get power good? Let's check the resistor. Oh, this is a lot. 500? 500 sounds too much. $556. You know what? Let's measure these two here, this one and this one out of circuit. Whoops. We'll sort the transistor, the diode later. So once again, so internal resistance is 0.5, so we can get the exact measurement. So we have 200 kilo ohms here. And this is open line. This clearly open line, you see? This is why we always have to check resistors with a big value out of circuit. So we have a voltage divider here with one resistor, 200 kilo ohms to ground, and another one where we don't know the value. What should we do now? It is clearly written what I have to use here. A 100 kilo ohms resistor here. This one here, this is connected to the ACO key line. Here is R1 and here is R2. 200 kilo ohms, 196 to be exact. So we'll replace this resistor with 100 kilo ohms and hopefully this will enough so we can start the board. So we have light. Here we don't have voltage. What with the power button? $400 millivolts, which is not enough. This clearly can't work. Let's remove power. Beep mode. Which pin is it? No pin, okay. Which pin is it? Seriously? What is wrong here? Okay, after further stepping, I found the next blown resistor, which is this one here, PR4453. In the configuration with the ISL 95522, it is supposed to be connected to ground, so a 0 ohms resistor to ground, as you can see here, on this line here. Yeah? And when I measure pin 3 at the actual board, when I can measure over 22 kilo ohms, which is way too much, because on this side we have indeed the ground line, see on the multimeter. Alright, so this has to be replaced with a 0 ohms resistor. So here we go. Zero ohms. So maybe now. No. No. .3 not present. Same with the voltage at the power button. No change. Although this resistor is fine now. So yeah, we'll dig further. So I did some further inspection and now it comes really bad. Look what I found. This is the resistor I've replaced right now, yeah? So these resistors are related to clock and data lines connecting to the M controller, the Super I/O, yes? So resistance mode. So this is a data line, 4.7 kilo ohms to ground, and this is a clock line, 310 ohms. Now what do you think is wrong here? Ground plus 3 volts, 500 milliamps are enough. So here in the middle is the M controller. Now see what happens. Can you spot that? Maybe like that maybe. Once again. Can you notice that? It is the M controller warming up from a 300 volts short. Once again with macro lens. So where are you here? Here's the M controller, yeah, all right. Look at the M controller. All right. Is shorted via the clock line. This means replace and program in this case, which is actually a hard job since the M controller is very rare. Under the microscope, here it is a KB9542 and now it comes QF2. It is a rare and expensive M controller. We don't have schematics for this motherboard, so yeah, I have to I have to come with my experience programming M controllers without knowing anything. I've recorded a video about this topic a few weeks ago, so if you like, watch it. And meanwhile, I try to read something out of it. Whether I can get the dump from this controller by any chance, because it is at least partial dead, maybe it is enough function left so I can get the dump, the firmware. Alright, so I have set up the Vertianov programmer accordingly, and yeah, let's see whether we can still get some life out of it. So here we have our Vertianov software. Select mode ENE, because it is a ENE. Board number LR-L 011P. Cable, we have a 32-pin FFC cable used, and it is one-sided. Now we'll send the settings to the programmer. It tells us how we have to connect it. Close. And now we'll supply power. Done. Check connection. And indeed we have access. Let's read the dump. And it seems to work. Weird enough. Perfect. Now we have the dump, and hopefully it is not corrupted at all. However, I've talked to my friends on the electronics repair resources area Discord and also of the IT jungle Discord, and they already sourced the M controller firmware for me. So actually I have 3 dumps right now which I can try, so I'm pretty convinced we will make progress as soon as the controller arrives here, which will probably take 2 or 3 weeks, so we have to leave the board aside for now. But the M controller we'll remove before. So I guess the board is warm enough now. I use a simple preheater for such cases because we had this mess with the thermal dissipation before, and I don't want to take any risk. So we'll try to make the process as easy as possible, so we don't stress the board more than necessary. And now the process should be fast and easy. Let's see. Hot air. 540, let's say 30% airflow. Where is my tweezer? Here. Oh, careful. Here we go. Okay. So this was a nice and stressless task. Let's clean the area fast. Yeah, I think this is good enough. Let's clean this area here. This looks nice, no? Very nice. So, and why did I clean the pads? Because we solder it by hand, of course. The replacement will be soldered by hand. So we don't stress the board more than necessary to stay safe. Like I always do. Okay? So almost nothing can go wrong. And nobody has to blame any Chinese sellers or similar. Nobody to blame except ourselves. Perfect. So let's check the clock rail again. So the lower one was data with kilo ohms, right? Now mega ohms even. Mega ohms. Okay, and the other rail also mega ohms. You see? Short is gone. Issue confirmed. Confirmed. The only thing we have to do now is to source the controller and to program it. And hopefully, hopefully this will be enough to let the board work again. Hello! So, 8 days later and the replacement controller has arrived. KB9542QF2. 30 euro. No joke. 30 euro. I mean, I have spent 10 euros, 15 euros, even 20 euros for an M controller before, but 30 euro? What is a sort of pricing? However, let's switch to the microscope. So here is our expensive friend. Let's start soldering. One here and one drop here. So let's see. How we can do that. I have diagonally soldered the pins here, so I have it a lot easier with the other pins. It's already in place, so no issues from here. Because of misalignment. So let's see what we have here. This pin is a bit bent. I don't like bent pins. The other pins are still okay. Yeah, so let's move on and solder these pins. Good, let's remove the last bridges. This bridge is gone. Now this one also gone. You see? No solder wick necessary. So why am I soldering the M controller without hot air? Like the great Serene does or other technicians? Well, the answer is these controllers are actually quite sensitive to heat. And it is possible you will kill them with the heat. So people who know me also knows I'm always trying to minimize the risk while my repair attempts. So for this reason, oh here this pin is loose. For this reason I always solder M controller with the iron. So the classic way. Alright, good. So which pin was it? Here, this one, no? Ah, come on. Wants to be annoying. So this pin is soldered now, bridge is removed. So once again, my tweezer test, where I look whether any pins are moving. But I would say my job is rock solid. Agree? So this is our soldered M controller. Yeah, let's clean and inspect again. Is good or not? Huh? No, this job is perfect. Okay. So now we have soldered the controller. And now we have basically two possibilities, two options. Two possibilities. A, it is self-programming and we don't have to do anything. I'm very curious actually, but 90% it does not. And if not, we have to program it, of course. There's no other way. But let's try without programming first, whether it is doing anything. Power on. Let's see whether we have more luck now. Ground. And 0.6. Basically nothing has changed. Let's try with programming or what? If I remember correct, we had to short at the clock line, right? Let's double check. I've checked, of course. Short was gone after removing the controller. So charger is already plugged. So I think here was a short with no voltage, no? No? So here we have 3.3 and here we have 3.3, so absolutely fine. Alright? So this is solved. Still, let's check in resistance mode. So here we have mega ohms even. Mega ohms, and here we have also mega ohms, 8 mega ohms. Yeah, I assume this needs its firmware. So this was a success. Let's remove power from the board and also from the programmer. I'm so curious. You can't believe. So, and now we should be done. Let's plug a memory module, connect power, and power on. So now you can notice 37, 25, and drops to 18, 16, 13, 8 millivolts, 8 milliamps. Let's see whether it is doing anything. It is not doing anything. This is weird, goes up and down. Do we have to wait till the BIOS compares the programming or something like that? Or what is going on here? You know what? Let's try something. So here we have 2.5 and here we have almost nothing. Oh my god, it is on. Yeah, it is on. Yeah. It was an issue with this subboard, with this power button board. Was it auto starting or what? No. What did I do? $200. Here we have almost nothing. Here we have 2.3. How did I manage to power it on? Any idea? I think this is my power button here, the 2.4. What do you think, huh? It's the third pin from the left. Let's check where's ground. So basically pin 2 and 3 shorting together, alright? Power. So and now we'll short pin 2 and 3 together, alright? Now. and no. How was I able to power it on, huh? Yeah, now it is on. Yeah, now it is on. Yeah. So let's sort this sorcery with this power button board. So what is wrong here? Why don't we have any connection? Do I have to replace a connector or what? The ribbon is good. The problem is, on this side I have ground here. Let's go with meat mode. I have ground here, so to the left pins. But on this side I have ground here, so to the right. So in this case I need a flipped cable. Alright? So it has to be flipped at one side. Yeah, like that. It does not work because I have no continuity between this ground and this ground. No continuity. So I'm back. I took a rest and I've also meanwhile a small cold. Sorry for that in advance. I hope it will be not so annoying. So I have called back the guy who sent me this board, this laptop, and yeah, let us clarify the actual issue with this power button board. So the guy who sent me this device has actually replaced this FPC cable. So in the original cable was not like that. 6 pins, yes, but it was double-sided. So we have on one side we have the pads at the bottom, and on the other side we have the pads at the top, like that. So flipped. And I don't have such a cable. The problem is these connectors here have only contacts at the bottom, but no contacts at the top. This is why I can't use these cables. So what is the solution? Yes, I could order a new cable. I've already looked. I can only order from China, needs 2 or 3 weeks. Or, yes, we can change the connector with a connector with contacts at the top side. This is what we do now. Why? No. Perfect. So, this is our new subboard with our new connector. And well, it should work now, no? What do you think? Huh? Let's see. So, now we can flip the wire like that. Now, so multimeter test. So ground was here, and on this side is ground is here, right? Here. So the ground has to be reversed, and it is beeping finally. Yeah, now we have continuity between our grounds. You see? Almost everything is possible. So let's see whether our power button is working now. This is the most important part. So, power and on. 33, 22 milliamps, 16, 17, 20, and let's press the button. And it is powering on. The LED is not working. But it is on. It is on. Also, and the CPU is getting hot. Secondary issue. So, cold solder joint solved. Let's see whether the button works now. Whether the LED works now. And is working. Here. All right. Good. So, finally. So, hello. I took a rest for a while because of my cold and did a few last checks and wondered why the board is not turning on anymore. I'll show you why. So, 3.3 volts. Into the 3 volt supply. Here. Let's have a look. Let's see. I've already opened a jumper to make it easier to visualize. Look. Look. Can you see that? Yeah. Look. So what happened? The PCH decided to be not longer part of the game. It has died. And the board is a no-fix. Awful, no? However, before we made a great job, it was working and all this mess was cleaned. In the end, the PCH quit. And yeah, that's the end of the story. We can't fix them all, no? So as always, if you like my videos, I'm happy if you leave a like,